We're doing sodium and sulfur. Let's have, we want to do it. Glasgow. Sodium and sulfur. Tell me what the reaction would look like.
Na plus S.
Na plus S yields Na2S. And you put the 2 down there because you go sulfur each 2 and Na only donates 1. Then it's not diatomic, so I got to fix this another way. How are we going to fix this? There you go. And that's fixed. Everything with us. Are we in agreement that that's the reaction? That's step 1. Write down the reaction as it's written. Second part of the problem. Now we're going to start off. We're going to start off with 100 grams. I want to turn that into sodium sulfide. Ms. Jenkins, how do I do that?
Me? Oh, sorry.
I said Jenkins. That's right. My bad. Go ahead.
So times 1 mole. For 1 mole, it is 22.990.
22.990. You got that right off the chart.
Yeah.
That turns me into moles of sodium.
Yeah.
That's not where I want to end up, but with how many grams of sodium sulfide I have. So what's the next step?
I put it was a 1 to 2 ratio.
1 to 2 ratio. So where'd you put the 1 and the 2?
1 on the top, 2
So
on the bottom.
1, you make 1 Na2S for every 2 NAs. Agreed? Yeah. And that gives me an Na2S moles land. For every 1 mole of, for every 2 moles of Na, I make 1 mole of Na2S. Moving forward.
Yeah, and then you have to do for 1 times 1 mole of the whole entire, like Na2S.
You have to figure out what the molar mass of Na2S is, the way we'd say that. So I need 2 of the 22.990s.
And then you need 1 of the
Plus 1 of the
32.064.
064. Some double check me because I'm not actually looking at a pair of paper. Probably grab one. This is your homework. You weren't here for that either? Excellent. You trying to get help? Because that would be the hardest thing we did all semester. Okay, so that's good. Solve for 32.064. I like all that. Anybody disagree with that? Okay, you got a handy calculator. 2, menu. 2 times 22.990 plus 32.064. And I got 78.044. Is that what you got? So that'd be 78.04. So 1 Na2S would give me 78.044 grams. If I'm looking for grams of Na2S, sodium sulfide, that's going to be the answer I'm looking for, correct? So now I get out my calculator, which I had in my hands. That's easy to do. 100 times 78.044 divided by 22.990 divided by 2. And I get a whopping 169. I'm only good to 4 digits here, 5, 5. So 4 digits is my limit. Okay.
Would it be 170?
So
would you round up to 170?
So I'm going to go 169.7. So I got 4 good digits. Grams. All right, so if I use up all my sodium, that's what I end up with. Are we in agreement?
I don't really know what you mean by when you use up all this.
So if I take 100 grams,
Yeah.
I would have some number of moles. I convert it to moles. And if for every 2 moles, I make 1 mole of this, how many grams of that would I have? That's all we did. Is that okay? Now, that doesn't mean we have enough sulfur to make that happen. We don't necessarily know that. We do know if I had lots and lots of sulfur, I did 169.7 grams
Of,
of sodium sulfide.
okay.
Okay? So if I start with 100 grams, I can make that much as long as I got plenty of sulfur. But now I got to check the other one, don't I? All right, checking the other one. Mr. Galicia, you're up. No, same problem. We haven't finished, we haven't got close to finish yet. How many grams of sulfur do I start with?
100 grams. Wait, no, 150.
150 grams. How do I turn that into moles?
1 mole S.
1 mole of S has a mass of what? 32.0. We're using 6 4 because that's the one that's on the periodic table. I'm going to have to go figure out why those numbers are different. They shouldn't be. I don't think we've discovered in the last 10 years that the molar mass of sulfur has changed. Only that's likely. I suspect it's been measured well enough that that shouldn't be a problem. Okay, so then for every mole of sulfur, how many moles of sodium sulfide do I make?
1.
1. So 1 mole of sulfur gives me 1 mole of Na2S. Agreed? And then for every 1 mole of that, how many grams do I have? 78.044. Now it's back to the calculator, make it do all the work. Then a 150 times 78.044 divided by 32.064. And I could make, with just the sulfur, I can make 365.1 grams of sodium sulfide. Yes, sir.
Is the 78.044 from that equation right there?
He's right here.
Okay, so we just.
That's the molar mass of that. So usually that's going to be the same. I can't imagine. I'm trying to think if it would be the same. It's pretty much going to be the same every time. Yes, ma'am.
Will the limiting factor always be the smaller number?
Right, because I can make, with 100 grams of sodium, I can make 169 grams of that stuff, of sodium sulfide. With 150 grams of sulfur, I could make 365 grams. What are we going to run out of? I'm going to run out of sodium because I can't make as much. Okay, so
Which one you're going to run out first?
right, and the one I run out is the one that makes the least amount when I'm done. Is that okay? Okay, so now look at this. Okay, so if that's the case, we got to answer these questions on the bottom, which we have not yet answered. Here they go. Question number 1, what's the limiting reactant? Okay, so what's my limiting reactant? So what is it? What am I going to run out of? Sodium. The reactant is sodium. That's question number 1. So when I'm done, I'm out of sodium, and sodium is what caused me to stop making the reaction go. Okay? Next question is, how many grams of sodium sulfide would I make? I would make
365. Oh, 100.
That's what I figured out. How much can I make? With this much sodium, I can make that many grams of sodium sulfide. So 169.7 grams of sodium sulfide is what I can make. Okay? How much of the remaining reactant would be left over? How much sulfur would I have? How much sulfur would I have? Well, I started with 250 grams of stuff, didn't I? So I started with 250 grams of stuff, and I make, how much did I make?
Wait.
My hand over here. No, yes, hand over there. 169.7 grams is how much I made. 169.7 grams. And whatever's left over is going to be that sulfur that's just sitting there doing nothing.
Oh, so you're taking the...
How much I started with, which is 100 plus another 150 grams. So I started with 250 grams of stuff. And I made 169.7 grams of sodium sulfide. So what's left over has to be the sulfur that's just sitting there doing nothing, waiting for more sodium to make a reaction. All right, so now I'm going to do a little subtraction. I get 3 borrowed, 0 borrowed, 8. I got 80.3 in my head. I hope that was what the calculator says as well. Yep, okay. Grams, 80.3 grams of sulfur is how much is left over. So when I get done with this reaction, I'd have whatever this is, some sodium sulfide, and then I have some sulfur laying on the ground.
Because we don't have enough sodium to.
We don't have enough sodium to react the rest of the sulfur.
Yeah.
It's still sitting there, waiting for more sodium.
So.
How's that, Miss Adams? A lot to absorb in 2.3 minutes, or whatever gets bid. All good? All right, with that in mind, and with this as a nice example problem, do problem number 2. They all look the same. Yes, sir? Here, go donate blood.
Yes, sir.
So you're going to be gone for an hour.
Like 5 minutes.
Okay, they'll let you do it for 5 hours, 5 minutes. That's not allowed. You'll be 20 minutes before they put the needle in you. Then if you pump it out fast, that's 5 minutes. They make you sit there for 15. Oh well.